In the short calculation item, we're given that we have a precast concrete floor beam, so that means the unit weight is 150 pounds per cubic foot. It supports a live load of 100 psf. The span is 50 feet, and the beam is simply supported. We're asked to find the required design strength for flexure, that means the maximum moment, using the ASCE 716 load case combinations listed like we have over here to the left. Right? So recognize that we've got the 100 pounds per square foot. That means that we've got a pressure load over this 4.5 foot width along the 50 foot length, so that means that we can collapse that PSF down into uniformly distributed load. And of course, if we're assuming that we have a prismatic member, meaning that the cross section is the same all the way along its length, that means the self weight will also be then uniform along the length. And so we'll have two uniform loads, a dead load and a live load, that are of the same kind of pattern. Both induce a reaction at either end of WL over 2, the shear diagram popping up at WL over 2, coming down at W, and then ending up at minus WL over 2 and going back up to close off. And that creates then the moment diagram where the maximum moment is WL squared over 8. If you happen to remember that directly, you write it down, away you go. But if not, of course, that's the longer path that you'll have to go through. So in many ways, this item becomes go figure out what the individual applied loads are, and then we can combine them, find the worst combination of those, and then that we can go directly to then the maximum moment, which is what we've been actually asked to find. So let's go get the self weight of the beam. The area of the concrete is going to be, well, let's chop this up as a rectangle and triangle. We've got 1/2 feet times 4.5 feet plus then this area of the trapezoid. It's 1/2 foot at its base. It's 1.5 up at the top, so that would be then an average width of actually 1 foot, and then that gets multiplied by that height of 2 feet. So the area of the concrete is 4.25 square feet. So the self weight then is going to be the unit weight times that area, and so we have 150 pounds per cubic foot times our 4.25 square feet for the area, and that would leave us a self weight of 637.5 pounds per lineal foot. The live load that is imposed on the beam then is just going to be our area force, 100 pounds per square foot, times our tributary width, which we assume is 4.5 feet. We have to assume it because we don't have any other information to tell us anything else. So that would then give us 450 pounds per foot. Now you might think that it's obvious what load case is going to govern here, but we want to check to make sure that we get it right. Now there's only two that we really need to deal with, right? Because all the rest of them are emphasizing other load scenarios, right? So for the first one, we've got that our W sub U would equal 1.4 times WD. So that's 1.4 times 637.5, and that would be 1,485 pounds per foot. In the second load case combination, that factored load would be 1.2 dead plus 1.6 live, so 1.2 times 637.5 plus 1.6 times 450, and that equals, I slipped up a little bit there. That's the 1,485 pounds per foot, and the 1.4 times the dead from load case 1 was 892.5. check that. 1.4 times 637.5. I don't like any of those. Yeah, that's right. I didn't like that number, but it turned out that was 892.5 was the number. Okay, so the second case is the one that does govern in this case. And then, finally, we find our required flexural strength, because we know in this particular situation that M sub u equals our load times the span squared over 8. So that's going to be 1.485 kips per foot times our 50 feet squared divided by 8, and we will get a max moment of 464 kip foot for our required flexural design strength.